Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 1. In the last video, we have already discussed section 1 and today's lesson we will start from section 2. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 11 says the photograph shows a rocket. The rocket is launched vertically. The rocket's engines give a total upward thrust of 7.3 times 10 to 7 newtons. Calculate the initial acceleration of the rocket and mass of the rocket is given to us. I have seen most of the time many students, they will do question like this. They will write down first of all F is equal to ma, then they will simply write down A is equal to F over m, and then they will take this value of thrust, they will write down here 7.3 times 10 to 7 divided by mass of the rocket, and then they will get some value of acceleration. But this is wrong. This is not the net force, because this one is wrong and they will get the wrong answer because this is not net force. So this has to be the net force. So for Newton's second law, you need to understand this F is representing the resultant force. It's very important one. This is the resultant force. So in order to answer this question, first of all, we can sketch the free body diagram. So there are two forces acting on the rocket. One is the weight of the rocket. So this is mg, that is acting vertically downwards, and there is thrust force. So this one is thrust. And the value of thrust is given to us. We can also write on here. This one is the thrust, and value of thrust is 7.3 times 10 to 7, and value of weight we have 5.0 times 10 to 6 multiplied by 9.81. So we need to find out acceleration. So the acceleration will be equal to the net force, means the F net divided by mass of the system. So this is mass of the system. So very important one, this is mass of the system. So what is the net force in this case? Net force is thrust minus mg and divided by mass. So we have value of thrust here, that is 7.3 times 10 to 7 minus weight is 5.0 times 10 to 6 times 9.81 divided by the mass of the system. So the total mass of the rocket is given, that is equal to 5.0 times 10 to 6 kgs. If we solve this one, we will get value of acceleration, that will be equal to 4.78 meters per second. So this is our final answer, and this is initial acceleration. Now for this question has 3 marks. The first mark you will get if you have used this formula. If you have written this, you will get 1 mark, and the second mark you will get if you have used this formula. So you will get the second mark. So this is 1 mark here, 1 mark you will get here. So in the exam, always write down all the steps. Steps are very important, and the final mark you will get if you have got the right answer. So this is how these 3 marks will be awarded to you. So this is very common mistake. So this is very common mistake. Part B says give one reason why the acceleration will increase as the rocket rises. Little bit tricky question, but a practical question about rocket. So how we can answer this question? First of all, just imagine that we have a rocket. So this one is the rocket. So simply you can imagine this is rocket. So here is our rocket. You can also draw, this is head of the rocket, and this rocket is filled with fuel. So it is filled with fuel. So this is the fuel inside. So this is the fuel inside this rocket. And we can also imagine that total mass of fuel and rocket, let's say here is capital M. Now when this rocket is rising, this rocket will use the fuel, and so we can redraw this rocket now. So you can simply imagine again. So this is rocket, and here we have head of the rocket. Now the mass of the fuel inside the rocket, this has decreased because fuel is used up by the rocket. So now we can imagine the total mass of rocket and the fuel is small m. So mass has been decreased. So if we calculate acceleration here, we will write down this will be equal to thrust minus weight. So here we have mg, and this will be divided by capital M. And here if we calculate acceleration, this will be equal to thrust minus small mg divided by small m. Now if you compare these two equations, you will say this force, this one is smaller as compared with this one, so we can say, let's say this is F1, this is Fnet 1, and this is Fnet 2. So in this case Fnet 2 is greater than Fnet 1, because thrust is constant. And also if we compare the mass, this capital M with this small m, so small m is lower than capital M. So you can see in this case this increase, it means acceleration increases because Fnet will increase. As mass decreases, acceleration also increases. So it simply means that A2 and A1, if we compare, A2 will be much greater than A1. So that's reason acceleration will increase because mass will decrease. I hope this is clear to you. Let me show you the answer. In your answer, you can mention this point. You can simply say the mass of fuel decreases because fuel is used up. You can also say the resultant force increases because thrust is constant. And this question has only 1 mark. If you write down this point, you will get 1 mark. And if you write down this one, you will also get 1 mark. Question 12 says, a teacher demonstrated the principle of conservation of linear momentum using 2 gliders A and B and an A track. A has the same mass as B. A and B were initially stationary, then A was pushed gently towards B as shown in the figure. So this is representing the push. This arrow means the applied force on glider A. For part A, we need to state the principle of conservation of linear momentum. Principle of conservation of linear momentum simply tells us that for any isolated system, total momentum before collision is equal to total momentum after collision. Isolated system means that there is no net external force acting on the system. So for principle of conservation of momentum, always we need to define a system. So in this case, our system consists of glider A and it consists of glider B, and there is no friction between gliders and A track. So if there is no friction and our system consists of glider A and glider B, momentum will remain constant because this is an isolated system and there is no any external force acting on the system. In this case, we are also ignoring air resistance. So simply we can say for any isolated system, total momentum before collision is equal to total momentum after collision, and this question has 2 marks. Let me show you how you can write down your answer. In your answer, you can mention these points. In the first point, you can say for an isolated system. If you write on this point, you will get 1 mark. And the second mark you will get if you have written total momentum before a collision is equal to total momentum after a collision, you will get the 2nd mark. So this is how these 2 marks will be awarded. So it's very important you have to mention isolated system, as you can also say closed system. If you simply write down for a system, total momentum before a collision is equal to total momentum after a collision, that is not right. Your system has to be isolated system, or you can say if no net external force is acting on the system, then total momentum is conserved. So this is how you can answer. Very nice question. Try to understand what exactly you are writing, not just simply memorize and write down. You need to make sense what you are writing. This is real science. It's not magic, so you need to understand the reasoning. Part B says a magnet was attached to each glider. The gliders glided and stuck together. A data logger and sensor were used to record the velocity of A. The velocity recorded after the collision was half the velocity recorded before the collision. Deduce whether these results show that the law of conservation of linear momentum is obeyed. So this question is quite straightforward one, but there is a little problem with this question because they have mentioned there is a magnet attached with each glider. So you can simply imagine here is a magnet, so we can draw here. Let's say this is N pole of the magnet, this is N pole, and this is the S pole. Then here is another magnet is attached here. So this magnet has S pole here because they stick together, and this is the N pole. Now you need to understand there will be attractive force between these two magnets, so they will be attracted. It means both of them they have to move, but in the question they are assuming is that this one stay at rest, mean the initial velocity of this one is 0, this stay at rest until they collide, mean its initial velocity is equal to 0 before collision. So we can say UB is equal to 0, and we can say this velocity, let's say this velocity is UA and this one is equal to V. We can also assume mass of this one is M, mass of this one is M. Now if we use conservation of momentum, so we can say momentum before, this has to be equal to momentum after. Momentum before we have M times V because the velocity of this one is V, so this velocity is V, mv, and momentum of this one is equal to 0, and final momentum, they stick together, so the total mass is m plus m, and they move together with the same velocity, and that is half of the initial velocity, means v by 2. So from here you can see that we have 2m times v by 2, so this 2 will be cancelled with this one, so we can see momentum is conserved. So it means momentum is conserved in this case. But there is little bit problem with this question. They have said there are two magnets on two gliders, so it means there will be attractive force, so there will be force on this one to the left, so this will also move. But they are simply telling us that velocity of A is V, and after collision velocity of A becomes half. So it simply means that this glider just stays at rest. So you need to understand, when do question, try to understand and try to picture in your mind, not just write down what you have memorized. Physics is about understanding. Physics is not about reciting something, so you have to develop your understanding in that way. So I hope this point is clear to you. If this is clear to you, this concept is clear, now we can simply answer this question. For the answer of this question, so simply we can say, you can write down these points. You can say momentum is mass times velocity, and after the collision the mass that is moving is double, means we have 2m. We can also sketch this one, so you can simply imagine this one is A, and here we have this is B, and after collision these two masses they stick together. So we have A here, we have B here, mass of this one is m, mass of this one is m, mass of this is m, so this is 2m. So the initial velocity of this one is v, and the final velocity of these two is v by 2. Mass is double than the original value. Because velocity is half, its original value of momentum remains the same, so the law is obeyed. So this is how you can answer. Is a easy question, not very difficult one, if your basic concept is clear. Second part says explain why the force of attraction between the two magnets did not affect this demonstration. So this question is just based on defining the system. In this case, we have defined our system consists of glider A and it consists of glider B. Now, if we draw the forces on these two gliders, force on glider A, this will be to the right because this is attractive force, and force on glider B, this one will be to the left. And these two forces, they have the same magnitude. So the vector sum of these two forces will be equal to 0. So we have in this case F plus F, and the vector sum of these two forces will be equal to 0, because we can say this is force on B and this is force on A, because the force on A is equal to the negative of force on B, because these forces, they have opposite direction. So the resultant force on the system in this case is equal to 0. So simply we can say F net on the system is equal to 0, because these two forces are internal forces. These are internal forces. So that's the reason in this case momentum is conserved, because there is no net external force on the system, and these two magnetic forces, these are internal forces, and the resultant force of these two is equal to 0. So this is how you can answer. So let me show you the answer. In your answer, you can mention these points. First of all, you can say the gliders accelerate in opposite directions because the forces are equal in size and opposite in direction. Mean direction of acceleration and direction of resultant force on this glider has to be the same. So this is acceleration of B and this is direction of acceleration of A. So acceleration of A. So the resultant force on the system is equal to 0. You can also say in terms of forces, you no need to talk about acceleration. You can simply say force on A and force on B, they have equal magnitude but they are in opposite directions. So the resultant force is equal to 0. So that's the reason this demonstration is not effective, because these two forces are internal forces. So in this case, momentum of the system is conserved. So this is how you can answer. Question 13 says tennis players can practice using a tennis ball machine. The machine projects balls horizontally from a height of 2.54 meters as shown in the figure. For part A1, show that the time taken for a ball to reach the ground is about 0.7 seconds. If you look at this question, for this question we don't have any information about horizontal motion, so we have to look at the vertical motion. For vertical motion, we have the initial vertical velocity that is equal to 0. So in this case, we have to consider vertical motion because we don't have enough information about horizontal motion. And for this question, we have the vertical displacement SV that is equal to 2.54 meters, and also we have vertical acceleration that is equal to 9.81 meters per second We need to find out value of time. So this is what we need to find out. We need to find out value of time. So how we can find out value of time? So simply we can use S is equal to UT plus 1/2 AT square. Acceleration is constant, so that's the reason we can use this one. Acceleration is only due to gravity. In this case, we are ignoring air resistance. Now simply we need to plug in values. Initial velocity is equal to 0, so it means this term will be equal to 0. So simply we left with S, and that is equal to 1/2 AT square. We need to find out value of T, so we can simply write down T will be equal to 2S divided by A and the square root of this, and we can plug in values and we can find the answer. So in this case, you have to define one direction as positive. So in this case, I'll be defining down is positive because these two quantities will be positive. Even if I take up is positive, negative will be cancelled with negative. For simplicity, I'm taking down is positive. If I take down is positive, this displacement is downwards, it means this displacement is positive and acceleration is also positive. So I can simply plug in values here. This is 2 times 2.54 divided by 9.81, and if we solve we can find the final answer. That will be equal to 0.72 seconds. So this is how we can answer. This question has 2 marks. The first mark, if you have used this formula, you will get 1 mark. Then the second mark you will get if you have got the right answer. Second part says the ball lands on the ground at a horizontal distance of 17.89 meters from the machine. Calculate the velocity of the ball as it is projected from the machine. So this question is simply telling us that this distance, the horizontal displacement from the machine, this is equal to 17.89. So this is 17.89. It's very important if you label this one. We need to find out the initial velocity, means we need to find out value of u. This is value of ux, horizontal velocity. As there is no force along horizontal, so simply we can say s will be equal to ut plus 1/2 at square. As there is no force along horizontal, it means that acceleration will be equal to 0. So simply we left with s is equal to u times t, and we have already calculated value of time in part A. T was equal to 0.72 seconds, and we have value of s, so we can find out value of u, and this is over ux. We are talking about horizontal motion, so ux will be equal to sx divided by time taken. So sx is 17.89 meters, and this is divided by time, that is 0.72 seconds. So the answer for this question will be equal to 24.8 meters per second. So this is how you need to answer this question, and this question has 2 marks. The first mark you will get if you have written this formula, and the second mark you will get if you have got the right answer. Part B says the initial velocity of the ball as it is projected from the machine can be increased. Means this component of velocity can be increased. We can simply say this is ux. Explain how increasing the initial velocity would affect the angle at which the ball hits the ground. Means angle at this point. So first of all, simply we can imagine the initial velocity, means horizontal component of velocity, is equal to this one. So we can simply draw one small arrow here. This is representing initial horizontal velocity. Horizontal velocity will not change at this point and at this point, because this velocity and this velocity has to be the same. In these two component of velocity has to be the same, because there is no acceleration, there is no force along horizontal. We are ignoring a resistance in this case. So this is at one instant. We can say horizontal component of velocity is equal to this, and at that instant we can also consider vertical component of velocity. So let's say this is vertical component of velocity. We can find the resultant of these two. So simply we can draw this arrow here, and we can find out the resultant of these two. Means the resultant velocity when it strikes the ground. So the resultant velocity in this case simply will be equal to this. So this is representing resultant velocity. We can say this is vertical component of velocity, we can say Vy, and this one is horizontal component of velocity, so this is Vx, and this is the final velocity when horizontal component of velocity is equal to this, or you can say when initial velocity is equal to this one. An angle with horizontal, we can say this angle is theta. This angle is theta. Now in this case, for this question we need to understand, is this velocity changing or not? This velocity simply we can find out for vertical motion. 2as is equal to v square minus u square. For this question it is given to us that initial vertical velocity is equal to 0, because it is just projected horizontally, so this one is equal to 0. So we can write down v square in this case will be equal to 2as. A is constant, s is also constant. If we keep s constant, it means this v also remain constant. So it means this component of velocity will not change. So this is the first thing you need to understand. Vertical component of velocity is not changing. Now simply we need to look at horizontal component of velocity. So if I increase this component, just let's make it bigger one. If I increase this much, what is the new value of angle now? So now we can find out the new value of the velocity. So this vector you can draw here, this is the vertical component of velocity, and the resultant velocity in this case, we can take this arrow, we can redraw this one, so we can redraw here. So this is here. Now we can draw the final velocity at this point. So I'll be using different colors. So let me use pink color for this one. So I can draw this here, this one here. Now if you look at the angle, so the initial angle we have this one. So this was our first angle. So this was our first angle, you can see here, and our new angle is this one. So I can say this is theta 1, this is theta 2. Now you can see in this case theta 2 is smaller than theta 1. So it means angle decreases. So we can simply say angle decreases in this case. Why angle decreases? Because horizontal component increases. So that's the reason angle with horizontal decreases. We can also understand this one with the help of tangent of theta. So we can say tangent of theta. Tangent of theta will be equal to Vy divided by Vx. So from here we can say theta will be equal to tangent inverse Vy divided by Vx. So in this case this component remains same. So if this component increase, angle will go down, angle will decrease. So these are the points you need to understand. In a simple language, one point you need to understand, vertical component of velocity remains same. So this component remains same. This is what you need to write down in your answer. This remains same. The second point you need to understand, as this component increases, angle will decrease. Angle will decrease. You can also use this equation. You can show this one. And this question has 3 marks. So if you write down these 3 points, you will get 3 marks. So that's all what you need to understand. I try to explain you in a simpler language and in a beautiful way, so it makes sense to you. I hope this question makes sense to you. This question is a bit tricky one. Now let me show you the final answer, how you can write down your final answer. In your final answer, you can mention these points. So I will clear this ink so you can see the final answer. In the final answer, we can talk about these points. The first point, you can say horizontal component of velocity is larger, has increased. Vertical component of velocity is not effective, remains same. So tangent of theta is equal to this. So theta decreases. So this is how you can answer. That's all for today's lesson. I hope this video was helpful. If this was helpful, please like and subscribe, and also leave some comments in comment section. And also if you need more help and you wanna support this channel, please join Patreon. See you in next video.